Okay, it's Tuesday, programming, day 5, we are in week 3, had that class already. Cyber defense, Wednesday, okay, so you can attend. Today, we went through a steps to a solution, talked a little bit about assignment 1, and we took the quiz. We talked about why top-down design. We gave some complex programming situations where the software can't be wrong, crucial things. And the students gave a whole array of those. So we have some kind of challenge. We have either we're going to create new software, or software to make something safer, or software to take care of a current problem, software to make life easier, maybe software to entertain, oh man, all those things. But we have something, we have a challenge or a problem, and so we have these 4 steps. We're going to analyze, we're going to design, we're going to develop, and we're going to implement. Alright, so let's talk just a little bit about each of those, okay? Analyze. You must understand the problem. You have to understand. You have to understand what you're going to put in, what you want out, and then you come up with a process that accomplishes that. So we talk about IPO. This little loop here is feedback. So when you're analyzing the problem, whoever created the challenge for you, you keep looking at it, analyze, do we understand? Keep looking at it, analyze, do we understand? There's no sense designing if you don't understand. Okay? Then we make a design. Design again as feedback. We can make a flowchart that we think will represent this IPO, or we can do pseudocode. Flowcharts diagram, pseudocode text. So then we can reiterate those until we're sure the design is correct. Then we do a walkthrough. Get some test data. Get some test data, and we walk it through the designs, one or the other. We make sure that we're getting what looks to be the correct output with a particular input. Is the process working? Then, after we have iterated this enough times, so we know what we want, we've got a design, now we can go ahead and develop the code. We can actually take the design and code it. And here's a case where you could pick which language. It doesn't have to be Python. I mean, it will be Python in our class, but it doesn't have to be. You can code it in any language. In some cases, you could code different parts in different languages, so that's probably not done much anymore. And then we've got a feedback here, right? Test it, run it, test it, make adjustments, and so forth. So we keep doing this until we feel like we've got a solid piece of software that we can implement. Of course, even though you implement it, you're still going to have some bugs, and you might have to, but if you have some major things, what happens here is you go all the way up here, determine exactly what the problem is, analyze it, design a patch, write the code for the patch, test the patch, and then distribute the patch. Right? Updates. I suppose anybody who's worked at all with computers have heard of turn updates. Let's move on. So then we had a problem. We had the landing spots. So the idea here was we're going to create these landing spots. Okay. So we're going to paint those. Let's say we're going to paint them maybe red. Okay. And we're going to create this border here. Okay. So we're going to have how wide it is, the border, and how big the circle is. Okay. So we have the diameter, the width of the band. Then we know some number, like how many gallons of paint it takes per square foot. I think the example I used, 2 gallons per square foot. Sounds like a lot, but we're going to make the mark practically forever, maybe. So then we have the input. Okay, what we want out is how much paint to order, so that we can paint that circle. So then the students figured out the process. Okay. I started a legend down here. Here's the IPO. Right? You got to understand the problem, and then you have to design the IPO. That's all analysis. The legend, we can start indicating what we're going to use for variables. And once we're sure, we've got the we feel pretty confident that we have the, let's say, the IPO figured out, and we've started designing here, then actually start putting together in some type of flow. Okay? How's it going to flow? This one's pretty easy. It's just sequential, one step after another. I've got a start and a stop. Initialization, we're going to input some information, then we're going to process, and then we'll output, and then we'll stop. Flow lines touch, box is complete, have a start and a stop. And then if we're doing pseudocode with this, it would all flow straight down. You could have the word start, initialization, input, let, however many calculations you need, print, stop. All right. Well, that is it for today. Actually, I have one more comment. The students should be, in fact, I'll just add a page. Students should be looking at assignment 1. Read through the information, make sure you understand, do an IPO, make sure you understand what you're doing, and then go ahead and start doing your flowchart pseudocode. Okay? We are going to look at those during the next session. We're going to see what you have started. That's it. Now we're done.